Alright, I've just touched off the top on the blank and I've zeroed that out. And the difference between the top of the blank to the top of the gear works out 110.325. So that's our difference. We've got to come up a fair ways on that. 110.33, that's close enough. That's within 0.05. So we'll leave it at that. Oh, do you ever have any of those days where you think, what am I thinking? Alright, I was hoping just by taking the handle out of this lock here that I would clear, but the collet, or the nut on the collet, is actually just going to hit that. I'm okay with the actual lock, but the locking nut is what I'm going to hit. So to get that out, I've got to strip everything back down again, take it out, put it back together, re-zero it all up again and come back to this setup. So that's what I'm going to do right now. So, oh dear me. Alright, there's no other way around it, just got to go ahead with it and get it done. Alright guys, we're back again. It only took about 10-15 minutes to get this back to the stage again, everything reclocked up again. One thing I forgot to show too is how I set the rotary table up square on the table, and I just use a 12-inch tri-square across the table and across the back of the rotary table. Squares it up, lock it down, and obviously we've got the big angle plate backing up behind it. I'm hoping this is going to be a fairly rigid setup, but we're going to find out on the first cut. So we're about to do that now, and let's see how we go. Only 127 of these things to do. I'll cut the first one by hand, then we'll go into auto mode. So we're going a depth of 3.85. Alright, that cut beautifully. Very, very rigid setup. I've just got to remember each time to lock up the back lock on this. So we've taken this one out to clear, but we've still got that one in the back there. Alright guys, well, I'll keep going with this, and we'll bring you back intermittently and we'll have a look at the progress as we go around. Alright, tooth number 27. Oh, jeez. Righto, well here's the money maker. Let's see what we've got. And that looks perfect. That looks spot on. Alright, so let's just cut this first tooth again. I've cleaned it up. Let's just see what we get. No, it's perfect. Alright. Oh, thank goodness for that. Alright, well let's get this stripped down now and let's see what we've got. Okay, I'm just going around this again, just as a spring cut. There's only a couple of tenths in it, I reckon. But let's go through the exercise anyway. Righto, last couple of teeth on the spring pass. Alright, I reckon worst case I've only taken a few tenths of a thou off each one. It was only just rubbing, but yeah, absolutely spot on with the indexing with this electronic division setup. So very happy with that. Be very, very hard to cut 127 tooth gear using plates on a dividing head. You know, prime numbers are awkward. You could possibly do it compounding, but I don't know how you do that. Anyway, this one's finished, so I'm going to get this off, get rid of the burrs, give it a clean up, and let's see how it all looks, eh? Alright guys, it's not often I get to show this attachment. I don't tend to use it that often. It's the slotting attachment that I built for my Bridgeport mill, or Bridgeport clone mill. I didn't actually show a video of the building of this, but I did do a video of the full breakdown, so you can sort of see how all the components work inside this and how it operates. At the moment I've just got it engaged into the ISO 30 taper. Got that locked off with the extension drawbar, you can see up there. I haven't knocked off the clamping screws yet, so it's quite free to turn on the quill. I'm just going to square this up first. That's a fairly simple job. I just remove this bolt out of here. And I've got that machined face across there. I can put a tenon block into the T-slots, push it up against that, and then I can then lock it off. And that gets it squared up for us. Alright, well I'll get this all set up. We'll get the plate in place, and we'll make a start on cutting this 6mm keyway. Alright guys, I'm just squaring up the gear at the moment. Now the way I do this, and guys have different ways that they set up for slotting. On my surface table I've set up a center line all the way through, and I've also marked out the profile for the keyway cut. Now I've just got a bit of wire that I've ground with a point on it, and just a bit of blue tack, and I run that backwards and forwards along that center line, and we square up that gear. And that's running dead plumb all the way through there. Alright, we'll get that clamped up, we'll get it in position, and we'll start slotting our keyway. Well, as you can see, I've got two small scratches down there, so my tool, I'm fairly happy that that's nice and square. From touch, we're going to go 3.2mm. That gives us a little bit of clearance on the top of the keyway. I'm in line with my marking out, so let's make a start. Righto, that's it, done. Alright, I'll get that cleaned up and we'll get it sitting into place and see how things are looking. Alright, there's a Keyway cut. I'll get a bit of key steel. That fits in there beautifully. So very happy with that. Alright, well we finished this job now. Let's get it set up onto the banjo on the back of the lathe and let's see how it performs, eh? Alright guys, let's get these fitted up. So this is our 50 tooth gear that we cut up a little while ago. I've got that spaced in the back there. The smaller gear. And this is the one we've just cut the Keyway on. Right, that's it. He's on. Beautiful. I just need to adjust the banjo centers up for these new gear sets, but I'll do that off camera. And we'll come back and have a look at how the whole show looks. Alright guys, that's everything done up. Now, I don't recommend you do this, but we'll call this fault finding. Let's just run it and just overcome the limit switch here, and we'll have a look at it. I'll run it in low. Well, that's good. Let's run it in high. High gear. Alright guys, well I'd call that a success. That's a 127 tooth change wheel gear cut, Keyway cut, and we've cut 3 or 4 of the smaller gears to make up the change wheel set. So now I can cut all the imperial gears, or threads I should say, and all the metric threads. So very happy with that now. Just keep an eye on this over time and we'll see how it performs, but I'm not expecting it to have any issues at all. Right. Let's strip this off and let's go through some of the problems I did have, and we'll show you what happened. And I don't think it's going to, well, it won't cause us any issues, but I think it's important that we show you what happens when you lose a little bit of concentration. Alright, let's look at one of the problems that I came up with on this gear cutter. Let's flip it over so I can find them. Now I've got 2 teeth. There's a tooth there. And there's a tooth there which has a section missing. Let's have a look at it. You can see it a bit better on that one there. And that's the second one there. So it's taken away probably about 1/3 of the tooth width. Now what was happening there was when I was cutting, I'd let the cutter run past a few mil, then I would blow the chips out with air and then run it back as a climb cut just to take the spring out for the cut. Problem was I was setting the camera up to show the digital indexer and forgot where I was. I hadn't retracted it, rotated it, and it's just taken a chunk out as it's gone round. And that's what happens when you lose concentration. What I ended up doing after I did it to the second one was winding it back, cutting the tooth, winding it back, cutting the tooth, going all the way around, and then going all the way around again to do a spring cut, rather than trying to do the spring cut as a climb, because I knew if I did it twice I was going to do it again. So yeah, anyway, just what happens when you do lose concentration. This isn't going to cause us any issues at all. The loadings that these are under are very minimal. If I ran did a calculation on the tooth strength, and the face wear, I think you'd find you'd end up with a 6mm face gear would do the job perfectly. There is a clutch in this apron which does protect from any overload, so that's handy. So if you're running full load torque on the motor, that might be a different issue, but the fact that I do have protection there as well means I haven't got an issue with running these at all. But we'll keep an eye on it over time. But yeah, I think it's going to be fine. Just what happens when you lose concentration, fellas. Now the keyway we cut, there was a couple of ways we could have done that. Well, 3 ways I guess. We could have filed it in. We could have done a click spring and filed it in and fitted it. I could have machined up a bush and we could have broached it. Or the method that I chose there was to use my slotting attachment, which I hadn't used for a while, so I thought, well, why not? Bushes are good to make up because once you've made it up, you've got it for other jobs as well. So I was tempted to go that way, but yeah, as I said, we used the slotting attachment on the Bridgeport. All right, well that about wraps this one up, fellas. We're done. I have finished off the wipers on the tailstock, so I'll show you those in the next video, because I'm going to start making some machine feet to sit this on. At the moment it's sitting on timbers. I want to get it off those timbers fairly soon, so I've drawn up a design for the machine feet, and we'll get that on the go next. All right guys, we'll see you soon.